Could asteroids crashing into Earth have brought life along with them? To answer that and many other critical questions, a team of scientists and engineers are on a crucial mission to bring back a piece of asteroid Bennu before it possibly crashes into Earth.
This program was made possible by Desert Program Partners, Southern Arizona viewers supporting stories that educate, inform, and inspire.
It's a first for the United States, the chance to touch what might be the origin of life on Earth. In the spring of 2011, NASA put up nearly $1 billion for the nation's first space mission to visit, study, and collect samples of an asteroid. The OSIRIS-REx mission, expected to take 14 years, is headed by Michael Drake, a space exploration veteran.
This is a sample return mission. The real holy grail is to return, and we promised NASA at least 60 grams, we'll probably return a lot more than that, to Earth in the year 2023 in September. The team is multi-generational, so I have young people. Dante Lauretta, my deputy PI, is 25 years younger than I am. And then we'll have grad students, undergraduates, maybe as many as 100 undergraduates employed by the project.
We're going to work for the next 5 years to build the spacecraft, to build the instruments, to get the ground system ready. We're going to strap it onto a giant explosive and send it off into space. And that is a hold your breath moment because it's completely out of our control. We show up in Florida with a spacecraft, stick it on the top of that rocket, and trust the rocket team knows what they're doing. And they do. They're professionals, and they will get the spacecraft off the ground. But there's always the chance that something's gone wrong. There's something, a valve has stuck or something, and the system malfunctions, and either your spacecraft gets dropped into the ocean or explodes upon launch. So that's the really big one. Once we're in space, we're much more comfortable. That's the environment the spacecraft is built for to operate.
The OSIRIS-REx team has a mere 5 years to design, build, and deliver their instruments for the launch, scheduled for September 2016. Just months into the mission, the principal investigator, Michael Drake, dies suddenly.
Obviously, the team suffered a major setback in September when we lost our leader, Mike Drake. And I was then asked by NASA to step up into the role of principal investigator. So a new leader changes the team dynamic substantially. So it took a while for us to regroup, mourn, and to focus on our objectives and get the team back up to operations.
Designing and building the instruments will take the first 5 years of the mission. The spacecraft will then spend 2 years chasing down its speeding target and 1.5 years mapping and studying the asteroid before grabbing the sample and returning to Earth. After the 2-year journey, the sample will land in September of 2023.
The biggest hurdle for me has been assuming the leadership position. You know, there's a saying that it's lonely at the top, and for the first time in my life, I understand what that means because the buck stops here. When I say something, even if it's an offhand remark, you know, in a hallway, the team will take it as direction and guidance, and the next thing I know, they'll be redesigning the project because of some crazy thought that I expressed out loud. So I need to be very careful about what I say. I cannot often think out loud unless I make absolutely clear to the team that that's what I'm doing and I'm not giving them guidance. So we're building test units of all of our instruments, all of our key spacecraft components, and we are testing them in flight-like environments. So we'll shake them harder than the rocket will shake it. We'll bake it hotter than the sun will bake it. You know, we're going to shock it. We're going to throw all kinds of electromagnetic interference at it. We're going to make sure it can perform in the harsh space environment. That gets us a qualified engineering unit that we can then go and assemble the flight unit based on the experience.
The OSIRIS-REx name is an acronym of the mission's concepts and goals: origins, spectral interpretation, resource identification, security, Regolith Explorer. 5 instruments on the deck of the spacecraft will explore the nearly half-mile diameter asteroid. These instruments will include cameras to see the surface, spectrometers to identify minerals, chemicals, and elements, altimeters to map the asteroid, and an arm with a collector to gather the sample. One of the most critical of these instruments is the set of 3 cameras called OCAMs.
I think that every single problem that you find is something that could have failed the mission at some point in the future, or dramatically reduced your ability to be successful. Basically, I've noticed, and it's probably a subjective observation that's not really objectively based, but I noticed that a lot of problems seem to happen on Friday afternoons. So it's just something you live with. We got one mission, it's going to go there, it's going to figure out how to operate around that asteroid, it's going to figure out the asteroid itself, it's going to decide where we want to go, it's going to go there, it's going to grab that sample, it's going to come back to Earth. All of those things, any one of which have been, a really complicated thing to do, we're going to do them all at once. So this camera system is meant to enable that whole feat.
The 4.5 billion-year-old asteroid Bennu was chosen in part because it may have organic compounds thought to be the origin of life on Earth. It's also one of the most potentially hazardous, with a 1 in 2,700 chance of colliding with Earth late next century. The main partners in the mission are NASA's Goddard Space Flight Center outside Washington, D.C., and Lockheed Martin Space Systems in Denver, Colorado. Lockheed Martin is tasked with designing how to grab 2 ounces of surface material, called regolith, and get it safely back to Earth. It's at Lockheed Martin that all the team's designs will get a final review.
My name is Ed Bashar. I'm the Deputy Principal Investigator, and I'm going to be talking with you. This is our last presentation of the day, and we're going to talk about science operations, the on-the-ground data processing and execution.
It's been a long couple of weeks. We've been here now 7 days. It's been very thorough and intensive, but I think it's going really well. The kind of review, like this critical design review, is essential for the success of OSIRIS-REx or any other spacecraft mission. This is a chance for the team, which has been very narrowly focused on what they need to get done, to have a chance for people to come in with a fresh set of eyes, scrub all of their assumptions and all of their plans, and really provide important guidance to make sure no mistakes are overlooked.
Because if we can speed that
it's actually NASA's chance to come in and give us an assessment of how well the design is done. Do you have enough confidence in the design that they should pay to have it built?
So now if we really get fortunate and we have more than one site for which we can deliver the spacecraft, that we can actually put the spacecraft in contact with the asteroid safely, that has abundant sampling material, the science team gets to actually argue a little bit about which site has greater scientific value.
Lockheed Martin had developed something called the TAG-SAM. It's touch-and-go sample acquisition mechanism. It's something that we developed to actually do a sample without needing a scoop or needing to be attached to what we're sampling.
Once we're sure we have the sample, the SRC, this is a sample return capsule, is opened up like a clamshell. The arm articulates, puts the sample into the SRC. It's latched down passively in the SRC. We cut the head loose then, back the arm out, close the lid to the SRC, and we're ready to come home.
The next step is we start building the spacecraft. So real flight hardware starts coming in here at Lockheed Martin and starts getting assembled into a vehicle that we're going to launch into space.
3, 2, 1, ignition main stage.
NASA's first successful launch of a spacecraft was in 1958. They've been doing space exploration ever since.
We have been involved in, I believe, every single NASA mission. We haven't led every one of them, but we've been involved in every single one of them. We may be the only university in the world that can make that statement.
The U of A has always been involved in planetary science, and when I say always, I really mean always. You have to go all the way back to the beginning when President Kennedy made his announcement that we were going to send people to the moon by the end of the decade. So the NASA engineers kind of looked around the country, and there was no one who knew anything about the moon. The only place that really had any of the expertise they needed was here in Tucson. Gerard Kuiper was making the maps of the moon here, and then he was invited to be an experimenter on the Ranger missions.
Unlike OSIRIS-REx, the Ranger missions weren't designed to return to Earth. They weren't even designed to survive a landing. The Ranger probes hoped to send back a few pictures of the moon before crashing onto its surface, but they kept failing.
They finally brought Gerard Kuiper onto the team and a handful of other scientists, including Ewen Whitaker, who was also here in Tucson. And together, this small team of scientists came up with a way to succeed at that mission and to get some photographs back so that we knew what we were headed for. We knew what the astronauts were going to land on.
So I was just one of the peons with the knowledge of the moon mapping in the background of my head. To pick someone like me, a rank amateur more or less, to put me on this team of people who are telling NASA where they can put their camera on the moon. Anyway, we took it all in our stride and did our very best.
This is a great day for science, and this is a great day for the United States. We have made progress in resolution of lunar detail by a factor of 1,000.
2, 1, 0, and liftoff.
After the moon, it was our neighboring planets on which NASA's space exploration focused next. One of the biggest breakthroughs came in 2008 when the Phoenix Mars mission successfully landed on Mars.
It was the first mission to be run by a public university, and it's not a coincidence that that happened here in Tucson, where for 50 years we had been building up the expertise in order to do a mission like that. That was a great moment when NASA and Caltech passed the reins to us for running the ground operations of this mission, which operated on Mars in 2008. The road to OSIRIS-REx was a long one. It didn't happen overnight. It didn't happen instantly. There were a lot of tries and fails before Mike Drake and Dante Lauretta got that mission accepted, but I think Phoenix was key in getting that acceptance.
William Boynton, OSIRIS-REx mission instrument scientist, has been exploring planets for 40 years.
Some of the differences between this mission and others is the fact that the scientific objectives are all geared towards one particular thing, and that is to choose the best site for collecting our sample. So all of our measurements are used for collecting the data we need. And the best site doesn't just mean the scientifically most interesting site. It also has to be a site that we can go to safely, and it has to be a site that has a lot of small grains that we can collect with our sample collector. We have to avoid areas of the asteroid that might be covered mostly with large rocks, since we can't really collect those large rocks. We only get one shot to do it. So this is why it's very important we lay it out and study it very, very carefully and make sure that we don't have any goof-ups.
I believe that this nation should commit itself.
Space exploration has long been an international priority. More than 50 countries have an active interest in space. Canada, one of the first countries with a satellite, is supplying the laser, OLA, which will be used to measure and map the asteroid.
This would be Canada's first sample return, and some of the things that we will learn in dealing with this little portion of the sample that comes to Canada is very important for both the OSIRIS-REx science objectives, but also learning how to handle samples from Mars in the future, which has long been a goal of the Canadian science community. There are challenges in terms of how our systems work, really our funding systems. I think the goals of Canada and the Space Agency and the goals of the United States and NASA are pretty well aligned on this mission, but we have different funding systems, and the timelines of those funding systems, they work quite differently. And when we're in a very constrained time window to get a mission together, they sometimes aren't the most compatible, and they can be as challenging or more challenging than some of the technical problems that we deal with on a day-to-day basis.
Just to give you a sense of how this is done, this is a wall at MDA near Toronto.
The Canadian Space Agency is a very important partner for OSIRIS-REx, but that team ran into a lot of political roadblocks. They're going to Canadian Parliament for the next few $1 million to build the flight unit for OLA. And that process got really delayed, and they were starting to get to the point where any more delay was going to mean they just simply could not build the instrument and deliver it to us on time. So we got good news. On June 12th of 2014, the Treasury Board approved OLA for flight hardware fabrication. So they have a new schedule. They're going to show up late, but we've already looked at it. We're going to figure out how to get them into the flow. They're coming in November of 2015. They were supposed to come in July of 2015. So they're going to be there well after everybody else, but we'll be waiting for them, and they're going to have to play a little catch up in terms of the system level testing, but we've got a plan to do that, and we look good. We can get them on and get them out to the asteroid.
Unexpectedly, geopolitical events are having a critical impact on the OSIRIS-REx mission.
This job always surprises me, and I had no idea how international headlines could have a direct impact on this mission. It turns out, recently, Vladimir Putin and Russia decided to invade Ukraine and annex Crimea, and it was big news in the newspapers. That's what everybody was talking about for a long time. And I didn't realize it, but a Russian company is building the main engine for our launch vehicle, for the Atlas V, for the main stage. So there was an embargo first, and it looked like we might not be able to import that engine and get it onto our launch vehicle. So that's a huge risk for us. I mean, I'm not directly responsible for the launch vehicle, but I can't get to Bennu without it. They're still in Russia, so we're watching the situation very closely. I've been told they'll be here in August, and so that'll be a great day when they arrive.
Scientists throughout the world have prioritized returning a sample from an asteroid. Japan plans to bring back a sample from beneath an asteroid's surface by dropping a bomb on their target.
The Japanese are kind of like our competitors, but also our allies, in science especially. So the Japanese Space Agency, JAXA, is getting ready to launch Hayabusa 2 in November of 2014, this year. And they're going to a carbonaceous asteroid. They're going to try to get a sample from its surface and bring it back to the Earth for analysis. So they're very similar science objectives to what we are doing. So the good news is that there's been a lot of goodwill and dialogue between the Hayabusa 2 team and the OSIRIS-REx team. The Japanese have a very different strategy for their mission than we do, and it's fascinating to watch it play out. They have a very ambitious mission. They have a lower budget and a leaner team, so they've incurred a lot more risk as a result of that. They're going to get out to their asteroid, and they're going to figure it out when they get there, and they don't even have a baseline plan for how to approach the mission other than some very high-level observing strategies.
Back on the OSIRIS-REx mission, planning and strategizing turn from talking into action.
So it's a very exciting time for us. We're moving into fabrication of the actual flight hardware. There's a variety of problems that start to emerge on the flight hardware. First of all, you'll get performance issues. You run an environmental test like the vibration test, where you try to simulate the rocket engine and the vibration that'll have on the instrument or the spacecraft. And for example, on the OCAMs, they saw some particles getting on the detector, being shaken off from some other component, which would degrade your image quality. So they got to get rid of all those last little design issues that they discovered on their engineering qualification models.
We do have a large budget. Our mission profile is, including launch vehicle, is just over $1 billion. OSIRIS-REx is a PI-led mission. Now, NASA headquarters is obviously the funding agency, and we have a partner, Goddard Space Flight Center, that helps us with the project management on a day-to-day basis. But the overall responsibility of delivering the mission within the promised budget and on schedule is the responsibility of the University of Arizona and the PI, Dante Lauretta.
When are we most active? What's happening? You can see here our most active day on Fridays. This is
schedule management is actually more important than cost management at this point. We're in a very healthy cost posture, but you simply can't buy more time for certain things. We've got a fixed launch date. We're going when we're going.
As the launch date draws nearer, the completed instruments are sent to Lockheed Martin for installation onto the spacecraft. 5 years of meeting, designing, planning, and building are drawing to a close.
Our spacecraft assembly is complete. We've been through our environmental test program, and we are getting ready to ship down to Florida to start integrating with the launch vehicle. We will be packaging the spacecraft up into its shipping container. We will load the spacecraft onto an Air Force C-17 cargo jet. We will fly from Buckley Air Force Base in Denver, Colorado to Kennedy Space Center, where we go into our payload handling facility and begin final preparations of the spacecraft. Once we're in Florida, our prime objectives are to do final characterization tests like the center of balance on the spacecraft, making sure the solar arrays deploy, and then a few last-minute checkouts, and we'll fuel it up, and we'll encapsulate it in the fairing or the nose cone of the rocket, and lift it on top of the second stage and get ready to launch.
Though 7 years remain before a piece of Bennu will be here on Earth, all eyes are focused on the launch. Unfortunately, concerns voiced 5 years ago proved true.
There's always the chance that something's gone wrong, there's something, a valve has stuck or something, and the system malfunctions.
Less than 6 months before OSIRIS-REx's scheduled launch, a possible hitch arises. The Atlas V rocket, propelled by those recently delivered Russian engines, is once again center stage. On a March 2016 mission to the International Space Station, an RD-180 valve had malfunctioned, shutting down the engines too early. Luckily, that mission was still successful.
We're certainly tracking the progress of the RD-180 main engines for the Atlas V. We do know there was a problem with the control valves on the launch for the last space station resupply mission. I'm very confident in the Atlas V team. They are very diligent in going through all of the components of that system, and they believe they've identified the root cause of that anomaly. We also have 2 launches on the schedule in front of us, so we'll be able to see the Atlas V perform a couple more times before we have to get onto that ride. It's important to note that we are fixed at September 8th as our launch date, and the team at ULA is doing everything they can to make sure we hit that date.
Status check.
Go Atlas.
Go Centaur. Go Muos 5.
RD-180s performing well for the set MR. All signatures look good.
With the engines working as they should for both the June and July launches, one unexpected risk is minimized, but the possibility of thousands of others remains. Momentum and apprehension now build for their own launch, which seemed so far away a decade before, but is now days away.
It's not a small thing to work so hard on something and then have it all come down to a single launch, a single day, a few minutes. That's what it comes down to in this as in life. We're very, very excited to be about to witness the launch, and we're ready.
Well, it's really wonderful to be here this morning in so many ways. This is a major milestone on a long journey. This week's been a circus in Florida, for sure. Lots of cameras, lots of media attention. We've done everything possible to make sure this goes right, so we're in the hands of the universe now.
I am really excited about this. I mean, it's something we've been working at a long time. I've been involved in a fair number of launches, but they're always exciting.
The origin of life on Earth is one of the biggest mysteries ever pondered by humans. To answer a question of that scope and complexity requires a special group of highly skilled people who are up to the task, the OSIRIS-REx team.
Greatest hope really is we're going to bring back a sample which is really going to be a gangbusters sample. It's going to have wonderful organic molecules in it and things like that that we perhaps have never seen in meteorites, or some very complex molecules. I think that's going to be really an exciting sample when we get it back and actually get it in our laboratories where we can analyze it well.
So I'm hoping that we find something we actually can't explain, and it really causes us to stop and pause and come together as human beings to unravel and understand what those signatures really are.
There's a lot of instruments on the...
I can't think of a better legacy for Mike to have. Mike always wanted to ask the difficult questions. And I think the mission is really a fitting tribute to his habit of asking those hard questions.
I can't think of a better way for him to be remembered than to be one of the original folks who conceived this mission.
Crowds are gathering in anticipation of liftoff of the Atlas V rocket and OSIRIS-REx.
Spacecraft to internal power.
Roger.
Status check.
Go Atlas. Go Centaur.
Go OSIRIS-REx.
Everyone is go. Standing by for launch. 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff of OSIRIS-REx.
The emotional roller coaster was incredible. Thinking about everybody who's poured their heart and soul into this program, those who are with us, those who are not with us. The moment of liftoff was like a dream come true. We just nailed it, and it felt amazing.
Now, Dante Lauretta, the OSIRIS-REx principal investigator.
Well, you'll all be real glad to know we got everything just exactly perfect. We've worked hard to get to this point. The best times are ahead of us. We are going to get to asteroid Bennu. We're going to map it. We're going to pick that site. We're going to get that sample, and we're going to bring it back to Earth in 2023.
This program was made possible by Desert Program Partners, Southern Arizona viewers supporting stories that educate, inform, and inspire.